Hi and welcome to our fourth troubleshooting video put together by our team here at DXB Pump. We're going to assume now that the engine is up and running, we have no charging issues, we have no fuel issues, and we can ramp the pump set up and ramp the pump set down with speed. But we're still not getting any liquid, or we're not getting the pump performance that we want out of the pump set. So generally speaking, if we know that mechanically the engine is operating how we want it to operate, but we can't get this pump to do the performance that we need it to do, then there must be a reason why the pump is not performing. And that is 80% of the time to do with the suction of the pump. We live in an atmospheric pressure of 1 bar or 10 meters of head. And these pumps are designed to do a suction lift up to around 7.5 to 8 meters. So anything greater than 7.5 meters of lift or 8 meters of lift means that we're going to struggle to get the pump to operate. So the first thing to do is to make sure that the water level is no greater than 7.5 meters away from the center line of the pump. If we identify that the water level is satisfactory and maybe we have a 3 or 4 meter lift, but we still can't get the pump to prime, it's worth checking to see whether this ball valve, which isolates the priming chamber from the air vacuum pump, the priming pump, is open. And to ensure that we know it's open, this handle has to line up with the pipework. The air travels from the air separation chamber to the vacuum pump. And it's important to identify whether this valve here, which is the frost protection drain valve, is in a closed position. If it's in the closed position, the vacuum pump will be able to prime through the priming chamber and bring liquid to the pump. Now, assuming that we've successfully primed the pump, but we still can't get to the performance that we need it to be, it's quite possible that the vacuum pump, which has the ability to actually get to a vacuum of almost negative 9 meters of lift, will bring the liquid up to the centrifugal pump, but then the pump is not able to maintain anything near 9 meters or even 7.5 meters, and it'll drop back to 3 or 4 meters. And this is to do with the NPSH or suction lift capabilities of the centrifugal pump itself. So we have to check that the suction hoses are not only of the right diameter in order to minimize the amount of friction losses in them, but we have to make sure that they're not damaged and leaking air through a missing O-ring, for example, between bower connections. And once we've identified that we've got a good suction line and that we don't have too much static lift, the pump should then go dynamic and achieve the pressures and the flow rates that we want out of the pump, and it's designed to do. If we get to a point where we've checked the suction hoses, we've checked the static lift, we know the engine's running, the pump has primed, it has gone dynamic, but we are still not achieving the performance, then we have to look at the discharge side of the pump. And it might be that the distance that we're trying to pump is too far, or the height that we're trying to pump to is too high, or, as is quite occasionally seen, somebody's driven a telehandler over one of our discharge hoses in the middle of the night and has created additional friction losses because the water is trying to go through a piece of pipework that's suddenly got a smaller diameter. So it's worth doing what we call walking the line. Walk the discharge line, make sure that there's no blockages in the line, and if there is no problems with the discharge line, then we can come back to the pump set. A more technical reason why we might not be achieving the performance is that the mechanical seal might have failed. Evidence of that will be some spilt oil or glycol in the bottom of the pump set around the bund. And because we now have perhaps a damaged mechanical seal, not only do we have lubrication fluid coming out, but we might have air being sucked in through the backside of the impeller, and that will stop water coming in through the suction and generating the flows and the heads that we want to see. So those are, generally speaking, the simpler reasons why, when we've got a great engine that's operating to where we expect it to be, but we're still not achieving the hydraulic performance of the pump, troubleshooting the system, i.e. the suction line, the static suction lift, and our discharge line and our discharge lift, troubleshooting that system, which generally generates 80% of all of our pumping problems, could be a solution to why your pump is not generating the performance that you think you should get. Thanks very much for listening.